Yes, I do say bottoms up that way in class because it helps stick in your mind. Bottoms up, throw your hands up, right? That's quite embarrassing, but it's okay. All right, so if you're in an algebra course or above, let's say a trig or a calculus course, you need to know how to factor. It's one of the most common mistakes I see in all my classes, whether it's a precalculus course where we focus on algebra, a precalculus course that's focused in trigonometry, or even a calculus 1 course. I wanted to make this video to show you how I like to teach my students to factor quadratic expression, ax squared plus bx plus c. The a value is a leading coefficient. So we'll first look at some examples that have a value of 1, and then we'll move on and look at some examples that have an a value of something other than 1. And that's where the mistakes get made. So let's check it out. All right, up here at the top right, I have the ax squared plus bx plus c notation, which is standard form for, say, a quadratic. When we say a leading coefficient of 1, that means the a value or the coefficient of the x squared term is 1. What are two numbers that multiply to give you the c value, which is -3 in this case, and at the same time add to give you the b, which is +2. So we need factors of -3 that add to give you +2. So think about what we're asking here. We need two numbers that multiply to give -3. Well, 3 is prime. The only factors of 3 are 3 and 1. Okay? We want two numbers to multiply to give a -3. So that means one of those two factors must be negative, the other's positive. So how can I combine a 1 and a 3 to multiply to give me -3 and at the same time add to give me +2? Well, we make the 1 negative. All right, there are your factors, x minus 1, x plus 3. If you FOIL that out, combine like terms, you'll see that that equals the exact quadratic that you see on your screen. All right, number 2 is x squared minus 4x minus 45. Okay, so this time 45 is not prime. There are other factors of 45 other than 1 and itself. So we need to think a little bit about this one. We need to say, okay, what are two numbers that multiply to give 45? Well, if you need to come over and do a little bit of scratch work, do it. So 45, let's see here, two numbers that multiply to give you 45. Let's start with 1. 1 and 45 is obviously a pair that multiply together to give you 45. Okay, 45 is odd, and therefore it's not divisible by 2. So think to yourself, is it divisible by 3? Well, yeah, it is. 3 times 15 gives me 45. Okay, but 3 and 15, I can't combine those in any sort of way to give me -4 in terms of adding those values. So let's go to another set. Is 45 divisible by 4? It is not, right? Try 45 divided by 5. You'll notice 45 is divisible by 5. In fact, there's a pair of numbers, 5 and 9, that multiply to give me 45. And if you look very carefully, in some sort of way, I can make them combine to give me -4. So again, looking at the c value, the factors of c must multiply to give me -45. So that means one of them must be negative. So now I look at the 9 and 5 and I say, okay, well, if I need these to combine to give me a negative number, let's just stick the negative in front of the 9. And so my factors would be x plus 5 because it's a +5, and then x minus 9. Check yourself. Again, FOIL it out and see if it gives you the x squared minus 4x minus 45, and it will. All right, number 3, x squared plus 6x plus 9. In this one, we want to, again, look at factors of c. This time c is positive. So when c is positive, that means the factors of c must be the same sign. So I'm either going to have two positive factors or two negative factors. You can't forget that two negatives multiplied together gives you a positive. So again, you can come over and do a little bit of scratch work. 9, obviously, you always start with 1 and 9 as a pair of numbers that multiply, or 1 and the number as the pair of numbers that multiply. And then just continue to think, does 2 divide into 9? It does it. 3. Well, yeah, 3 and 3. And that's it. That's all the pairs of numbers that you can use to multiply to give you 9. So how can I add one of these 2 pairs together and get 6? Well, keep them both positive, x plus 3 and x plus 3. All right. And notice these 2 factors are in fact the same. And so we could rewrite this x plus 3 times x plus 3 as x plus 3 squared. And when you get something like that where you have a trinomial that factors into a binomial squared, remember binomial means 2 terms, a polynomial with 2 terms. Trinomial means a polynomial with 3 terms. So here's 3 terms. When I have a trinomial that factors down to a binomial squared, that's called a perfect square trinomial. So keep that in mind for future topics. All right. So now let's look at some examples where you have a leading coefficient that is not 1. Let's do it. All right, here are 2 examples that have a leading coefficient that is not 1. So in number 4, we have 2x squared plus x minus 6. Number 5, 3x squared plus 10x minus 8. As you notice, the a values, the coefficients of my x squared terms, not 1. A lot of students mess factoring up in these cases. So I'm going to show you how I like to teach my students if I'm teaching this lesson in depth as opposed to just kind of reviewing it. There are many methods that are used to factor these sort of quadratics. So as I began my teaching career and noticed things that work and things that do not work, I stick to 2 methods to factor these types of quadratic expressions. One of the methods that I like to teach is to break up the b term into 2 separate terms and then factor by grouping. That is a very good technique as long as you know how to factor by grouping. Okay, so when you have a 4-term polynomial, can you group the first 2, the second 2, and so on? This video, though, I want to talk about something called a method that I call bottoms up. Wait, that's not the right song. Hold on. Either one. So think of these 2 songs. Bottoms up, right? Oh, that's embarrassing. Yes, I do say bottoms up that way in class because it helps stick in your mind. Bottoms up, throw your hands up, right? That's quite embarrassing, but it's okay. Now let's go through the steps of the method that I call bottoms up. What you first want to do is take the a and multiply it by the c. Okay, so 2 times -6 is -12. And then we want to find 2 numbers that multiply to give you -12 and add to give you the b value. So very similar to what we just did. We want to find factors of -12 that add to 1. Okay, so if you need to come to the side and do the pairs like we did in the previous screen, then do that. So obviously 1 and 12. One of our factors will be negative, but for now we don't know which one, so we're just going to write the factors of 12 first. Okay, so 1 and 12, let's see, 2 and 6, 3 and 4, and that's it, right? Those are the only pairs of numbers that multiply to give you 12. So which one of these pairs can you add together and get +1? Well, let's combine the -3 and the +4. Guarantee if you multiply those together, you get -12, and if you add those together, you get +1. Okay, so now the next step is to take those factors divide them by A. Remember what A is. A is the leading coefficient. So here's the A value, all right? Divide those by A. Now, we don't want to actually say, oh, -3 divided by 2 is 1.5. No, we want to keep these written as reduced fractions. So when there is a fraction that can be reduced, reduce it. -3/2 does not reduce, but 4/2 does. Now, the idea behind bottoms up is you always want to have a bottom of the fraction. So 4/2, 4 divided by 2 is 2, but let's keep it written as a fraction. Let's reduce to 2/1. And so why do we call it bottoms up? Well, you take the bottom of these fractions, 2 in this case, 1 in this case, and you're going to bring those up. Now, you need to be very careful. When we say bring them up, we mean bring it up to the left. So when I bring that 2 up to the left and give it a variable, this becomes 2x, and then that's a -3, so -3. There's one factor. And then when I bring that 1 up to the left, 1x plus 2. There are my factors to that quadratic. And I guarantee if you FOIL those binomials back together, you will get that quadratic 2x squared plus x minus 6. All right, let's look at the next one. All right, number 5, 3x squared, voice crack, 3x squared plus 10x minus 8. Multiply the a times the c. So 3 times -8, -24. Find pairs of numbers that multiply to give you 24. Always start with 1 and the number itself, and then just continue to think, okay, 2 and 12, 3 and 8, 4 and 6. Those are the only pairs. Now, I need these to multiply to give me a -24. So that means one of these must be negative. So please don't make the mistake to think that it's going to be 4 and 6. That can't be the case because one of my two factors must be negative. So you need to be very, very careful there, okay? So think about the other pairs. Look at them very carefully. 2 and 12. Well, guess what? If I simply make the 2 negative, then they will add together to give me positive 10. So there is my pair. Okay, so you do have to be careful with the signs. You have to think about that. All right, so take -2 and 12, divide those by a. A is 3, so I got -2/3 and 12/3. Well, 12/3 reduces to 4/1. Now I bring my bottom up. Bottoms up, bottoms up. Throw your hands up and give it a variable. So we got 3x minus 2. And then over here in this second fraction, we got 1x plus 4. So there you go. Remember the song Bottoms Up just to help you with the concept of factoring quadratics that have a leading coefficient of something other than 1. I hope this video helped. If you have any requests for any content, something that you need help with, please let me know in the comments of any video, and I will do my best to make some sort of long video, short video, some sort of content to help you guys out. But I'll see you in the next one.